Okay, so starts off with the binomial versus geometric. And how do I determine which one I'm using? Well, the binomial has a fixed or predetermined number of trials, and the geometric continues until the first success. Binomial will ask for a certain number of successes, and the geometric will ask what's the probability of the first success occurring, or when will the first success occur. So let's determine whether or not something is a geometric or a binomial. Assume that 13% of the population is left-handed and that we randomly selected 15, circle the correct distribution. The first lefty is the fifth person. As soon as I see the word first, this lets me know that I'm working with a geometric. Because it has to occur on a specific time, this means this is going to be a PDF. So this would be a geo PDF. And our probability, the probability is 0.13, and our X value in this case would be 15. Just a second, please. I'm gonna mess with the calculator. Just 1 second. All right. So probability, our p-value is 0.13, and our X is 15. All right. We can go ahead and solve it, but I'm not going to do that at this point. The first lefty is the second or third person. So in this case, we see the word first. So this lets me know that it's a geometric. All right. Now I have two values. And what I would probably do in this case is I would do the PDF for this plus the PDF of this, because it's either or is the keyword for add. So we have a geo PDF. 0.13 is still my probability, and then I need to do it for 2 plus the geo PDF 0.13 in the third person. All right. What is the probability that there are exactly 3 lefties in the group? Here we're looking for a specific number of successes. Because I'm looking for a specific number of successes, this is a binomial. Now, we already said that we had a sample of 15, and because it's exactly 3, this is going to be a PDF. So we're going to have the binom PDF. Our number of trials is 15. Our probability is still 0.13, and our X value is we want 3 successes, and that's our X. What's the probability there are at least 3 lefties in the group? As soon as I see the word at least and I want to have a specific number, I see I have a specific number of successes, this means this is going to be a binomial. At least means it's going to be a 1 minus situation. And we have more than one value because we can have 0, 1, 2, 3, 4, all the way to 15. So in this case, I'm looking for values all the way up to 15. Okay, so 3, 4, 5, all the way up. So this is going to be 1 minus the binom, because I have multiple values, that makes it a CDF of my number of trials is 15. My probability is 0.13, and I subtract out the highest value I don't want. The highest value I don't want is a 2. And you're like, well, why didn't you subtract out the 3? Don't take away what I want. I want a 3, so don't take that away. I want the 3, so you take away what I don't want, and the highest value I don't want happens to be a 2. So you can't take away my 3. All right, so this would be the work shown for this. There are no more than 3 lefties in the group, geometric or binomial. Once again, we have a certain number of successes that we want. Because we have a certain number of successes, this is going to be a binomial. And we have multiple values, and I'll show you that in just a second. But we have a multiple values, and I'll show you how I know this. Because it can be 0, 1, 2, 3, 4, all the way up to 15. And I want no more than 3. Which means I could have 0, 1, 2, or 3, So I have multiple values. So this will be a binomial CDF of, once again, our trials are 15, our probability is 0.13, and my highest value circled is the number 3. Out of 15 peoples, how many lefties do you expect? All right. We have an expected value. That's a keyword that lets me know I'm working with expected. And we're taking out of a specific number of trials. Because I have a specific number of trials, I'm going to have to use the binomial. So this is a binomial for expected values, NP, which is going to be 15 times the 0.13, or our probability. What is the probability that the majority is right-handed? All right, so in this case, we could have 0, 1, 2, 3, all the way up to 15. Well, the majority would be having 8 or more. So that's going to be multiple values, and there's specific values. So this makes this a binomial. All right, so this is a binomial, and we have multiple values, so it's going to be a CDF. All right, so this will be a binomial CDF, and I don't want to get into how this one actually plugs in, but right now, because that's, I think, it's a little bit complex. But this would be a binomial CDF because we have multiple values, and we know that we have a specific number that we want to have. How many must be surveyed until a lefty is selected? All right, so they're saying, how many do we have to survey until we get to the first lefty? Oh, first, geometric. But they didn't say where it occurred. So they want to know how many do we expect to have to survey. So this is going to be an expected value. The formula is 1 over P. So in this case, 1 over the 0.13. What's the probability that there's some lefties among the 15 people? All right, this means we have more than one, and we have a specific number of trials. I have a specific number of trials. This makes this the binomial, and we need some. We could have 0, 1, 2, 3, all the way up to 15. So anything greater than 1 would be some. Some might say it's greater than 2, but regardless, we have multiple values. So since we have multiple values, this would be a binomial CDF. So that gives us the difference between a geometric and a binomial. All right.